Okay, so welcome to the measurement unit. This is the first video in the first unit of the year, and it's really kind of a review for most of us. A lot of us have done a lot of measuring, and this is stuff that we've been introduced to. But I want to make sure that we start off the year understanding how to make good measurements and how to record those measurements and how to calculate those measurements. We do a lot of measuring in this year, so I want to make sure that we do understand how to do that. So we're going to start off with the metric system. So the metric system originated in France in the late 1700s with the meter. It has since evolved into this encompassing system of measurement known as the International System of Units. This is the official measurement system in place in nearly every country in the world. So take a minute and think about what this video is actually about and what I want you to get out of this lesson. At the end of this lesson, you should be able to identify the correct unit to measure a certain quantity, and you should also be able to use the appropriate prefix for that unit to measure a certain quantity. Now remember at the end, as you're taking notes, you're going to write a summary. So here's some questions to think about as you go along that you will need to answer. I want you to understand, what is the International System of Units and why is it important? Which three base units will be the basis for this trimester? So which ones are we going to use in this class? And which metric prefixes will we use most often in this class? And how do these prefixes change the meaning of the base unit it precedes? So those are your three summary questions. So if you want to jot those down, those are also linked in Classroom. The SI measurements start with a base unit that corresponds to a certain kind of measurement. These units are independently defined. For example, a meter is defined as the length of the path traveled by light in a vacuum in 1/300 millionth of a second. So these are units that can be defined by a certain standard. For right now, we are mostly concerned with 3 of these base units. This is really kind of cool because everything else that we're going to talk about this trimester will be based on 3 of these base units. So length is measured in meters, and meters is abbreviated with a lowercase m. Time is measured in seconds, which has the symbol S. And a kilogram is a unit for mass and is labeled kg. Now notice that the mass unit is somewhat unique, that it already has a prefix. We'll come back to that in a second and we'll talk about why. So let's do a learning check. What I want you to think about, indicate the base unit used to measure the width of this room. Is it going to be a meter, a second, or kilogram? How long does it take to answer this question? A meter, a second, or a kilogram? And how much flour do you add to your cookie dough? Are you going to measure that in meters, seconds, or kilograms? So pause the video for a second and answer these questions. So to measure the width of a room, meters measure length or width or height, some distance. So a meter would be the most appropriate unit to use to measure the width of this room. Second measures time. So when we say how long it takes, we're talking about an amount of time. So we would use a second. And then when we say how much flour, we would use a kilogram. If you're into baking, you will probably find recipes from different places around the world. Some people use, in the United States, a lot of people use volume to measure the ingredients, but in other places around the world, and even in the United States, a lot of people also use mass. So a kilogram would be an appropriate unit for that. So metric prefixes increase or decrease a base unit by a multiple of 10. So for example, kilo means 1,000. So putting the prefix kilo in front of a base unit increases the value of the base unit by 1,000. This allows us to convert between units in the metric system. So if we need to use a measurement that is more than a meter, we could use a kilometer. If you think about a parallel in the English system of measurement, a meter is approximately 1 yard in length. If we want to measure the distance across town, a meter would be too small. In the English system, measuring in miles would be more appropriate. In the metric system, we would use a kilometer instead. So a kilometer is just over half a mile in length, quite a bit smaller than a mile, but still a much more appropriate measurement than a meter. So the same thing happens in grams. A gram is actually a really tiny unit. If you think about how much mass a paperclip has, that's about a gram. So that's a really, really tiny unit. And it's not really appropriate to use in a lot of situations. So the base unit in the metric system is actually the kilogram. And kilo means 1,000, so we're talking about 1,000 grams. So when we say the base unit is kilograms, it's because it's just a more appropriate unit to use in pretty much anything that we're going to measure in our classroom. Now, there are a lot of metric prefixes. Some scientists spend a lot of time measuring little tiny things, while other scientists measure really big things. There is a prefix for any measurement that you want to make. Some prefixes increase the value of the base unit, and some prefixes decrease the value of the base unit. So these are probably the most common ones that you will see. Mega we see a lot when we're talking about data, like a megabyte of data is 1 million bytes of data. We'll also see giga and even tera now. Giga means 1 billion and tera means 1 trillion. So when you see those in terms of your data, that's what you're talking about. So notice the scientific notation is listed here. 1 million has 6 zeros. So its scientific notation is 10 to the 6th power. Kilo means 1,000. So a kilogram represents 1,000 grams. 1,000 has 3 zeros, so its scientific notation is 10 to the 3rd. Now look at centa. Centa means 1/100th. So putting centa in front of the base unit makes the unit smaller. If you want to divide a meter stick into 100 parts, each part would be a centimeter. Milli is even smaller. Divide that meter stick into 1,000 pieces, and each piece would be a millimeter. Notice the scientific notation here. Centa is 10 to the -2nd, while milli is 10 to the -3rd. They are 1 order of magnitude apart, and what this means is that there are 10 millimeters in every centimeter. Micro and nano are commonly seen as well. Micro means 1/1,000,000th. So take that meter and divide it into 1 million pieces. If you divide it into 1 billion pieces, you now have a nanometer. So they're very, very small units. To give you kind of an idea, a micrometer, 1 millionth of a meter, is about the size of a cell, like an animal cell or a plant cell. And nano is about the size of an atom and molecule. So kilo, centa, and milli are the most common prefixes that we will use in our measurements. So be prepared to know those at any time. All right, let's see what you remember. A mass that is 1,000 times greater than a gram. What prefix are we going to use for that? Kilo, milli, or mega? A length that is 1/100th of 1 meter. Are we going to call that a decimeter, a centimeter, or a millimeter? And what if we have a unit of time that is 1/1000th of a second? Will that be a nanosecond, a microsecond, or a millisecond? So pause if you need to and check yourself, see if you've got those. So kilo means 1,000. So if we have 1,000 times greater than a gram, we're going to call it a kilogram. 1/100th is represented by centa. Think century, right? So a century has 100 years in it. So centa means 1/100th of a meter. And 1/1000th, like a millennia, is 1,000 years. So a millisecond is 1/1000th of a second. Now let's look at our prefixes here in terms of abbreviations. If we have 1,000 meters, what would we have? A millimeter, a kilometer, or a decameter? 0.001 grams, that's going to be 1/1000th of a gram. So are we going to have a milligram, a kilogram, or a decigram? 1/10 of a liter, will that be a milliliter, a centiliter, or a deciliter? And then 1/100th of a meter. Milli, centi, or deci? Pause for a second and answer those questions. So 1,000 meters, kilo means 1,000, it's abbreviated K. So we have km is a kilometer. 1/1000th of a gram is going to be a milligram, so that will be mg. Deci means 1/10. This is when it's not as common. You don't see this as often. But 1/10 of a liter will be a deciliter, will be dl. And then 1/100th of a meter means centimeter, or cm. So one more. Think about what would be the best unit and prefix to measure your height. Would you use millimeters, meters, or kilometers? What about your mass? Milligram, a gram, or a kilogram? What if you're going between two cities? Would you use a millimeter, a meter, or a kilometer? And now say we want to measure the width of an artery, so a blood vessel in your body. Would you use a millimeter, a meter, or a kilometer? Pause and answer those questions. So your height is more likely going to be measured in meters. Most people are going to be 1 point something meters. Some people will get to 2 meters. That would be about 6 feet. So meters would be the most appropriate unit to use for your height. Your mass, remember we talked about grams being about the size of a paperclip. So we definitely don't want to go smaller. We wouldn't use milligrams there. So we would use a kilogram to measure our mass. Same thing with the distance between two cities. That's a really large distance. So a meter is about 3 feet long. So we wouldn't want to use meters to measure that. That would be a really a lot of meters. So we would use kilometers. Now the width of an artery, look at your hand. You can kind of see some veins and blood vessels in your hand. Those are pretty small. So we definitely wouldn't need to use meters with that. Absolutely not kilometers. So millimeters would be a much more appropriate unit to use to measure the width of an artery. All right, so at the beginning of this lesson, we had 2 targets that we were going to try and make sure that we understood at the end of this lesson. So can you identify the correct unit to measure a certain quantity? And can you use the appropriate prefix attached to that base unit to measure a certain quantity? In your summary, you want to make sure that you hit these 3 questions. And if you can answer these 3 questions, you've hit those targets. If these are looking not very familiar, if you're looking at these 3 questions and saying, I don't really remember what the International System of Units is and why it's important, go back. This is a video. You can rewind as much as you want to. You can go back and look at different parts of that video as you need to. So what's the System International? Which of 3 base units are we going to be using in this class? And which metric prefixes are we going to be using most often? And how do those prefixes change your units? So those 3 summary questions. And then don't forget your own question. You're going to clear up any confusion, add an example, or pique your curiosity.